So for the today problem of the day, I left and not able to solve. So now let's add up. mm, Now let's understand and let's try to solve this problem. So one thing is so sure that we have to use the CO of arithmetic to find the prime number. Okay. So what might be the code? Mm, Like a void helper int max element. So vector int vector bool. What will be the prime number and what will the sign? Maximum element plus one, right? And the false, sorry, and the true, right? So the prime first, it is the famous, it is a famous concept of a sieve of arithmetic to find the all prime number. Okay, so we use this formula if the prime we go like j is equal to I into I, j is equal to max of, oh sorry, here max of element, max of element, max of element, and the j plus plus, sorry, plus equal to I. So we have to put prime j is equal to false, right? And here just we have to return the prime number, sorry, prime. Now let's see how can we proceed, right? So in this question, this is clearly a question of a graphical approach, right? Because we have to jump, alternative jump. We can go from the present to the left or the to right. For the present index, we can go to the right and the adjacent element, right? And we, if the current element is the prime number, then we can travel to the any index which is divisible by the current prime number. So this is a clear approach of BFS level wise traversal. So let's understand this. So let's use here the first. Let's build a map. What for map? For storing all the indexes, position, and int maximum equal to 0. Let's build 0 and plus plus. So position nums I dot push back I, right? And the max is equal to max of max is equal to nums of I, this get, and the vector bool helper, oh sorry, time is equal to helper max, right? This will provide me the all the prime number. Now let's vector use a, sorry, vector bool. What can we build like here? First we have to build a visited area or scene. So let's build this like a, for the visited int n is equal to nums dot size. So for the visited at vector int vector bool visited and 0, and the unordered map, unordered set for storing the visited prime, seen prime, right? So now let's build the concept like int q, q, int q dot push 0 and visited 0 is equal to true, and the int the steps is equal to 0. Now let's use the खानदानी टेम्पलेट, दैट मीन्स जो पूर्वज हम लोग को दे के गए हैं, एम्प्टी, ओके, दिस int sj is equal to q dot size, and we travel level wise, so sj minus minus, okay. Now auto I is equal to q dot front and q dot pop. Now let's understand here, if the I is equal to n minus 1, then we have to simply return the steps, and if the I minus 1 greater than equal to 0, and okay, and this is not visited, I minus 1 is not visited, then we can do like what we can do, like we dot array dot push I minus 1 visited I minus 1 is equal to true, right? Now let's see for the if I plus 1 less than n, and visited, it's not visited I plus 1, then we have to push in vector, is sorry, in queue, and mark this as visited, uh, true. So this is the concept of now. This is the for the left side, and this is for the, sorry, this is for the left side, the right side, and this is for the left side. That means the from the current index, we can go from the to the left index, and to the right. Now let's check for the prime. So if if it is a prime, if it is a prime, not prime. So if it is a not prime, or it is a scene dot count nums dot I, then we have to continue, simply continue, right? Now if it is a prime, we have to visit, right? If it is a prime, so we have to visit like the indexes of that element. So let's check how can we visit, like it's x dot pos, okay, it's pos, I don't think so. Why pos? If it is a not prime, then we have to visit all the indexes, right? We have to visit that indexes which are not seen by the, okay, right. Now let's visit all the indexes pos numsi, okay, that's it. No, no, no. This is wrong. So we have a storing the element and its index, right? The question arises now. This is prime and count scene, right? Okay, 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 okay. You are right. Okay, so here the problem. This now let's check if position dot count not found multiply, then we have to continue, right? Continue. Else for auto idx ix position null. Then you have to, if it is not visited visited inx. So if it is not position visited, we have to put in it and mark this as visited, right? Now from this we have to, sorry, this concept, this is right. Let me put the precept. This 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 and scene dot insert num side right. Now now here let's step this. Now let's return Return the steps. Let's see this is running or not, or this give a TLE or a wrong answer or a compile time error. I don't think this. Whoa, whoa, whoa. This is submitted. That's a great. Let's see. What is this? Preparing the runtime environment, compile the coding and the bits. That's good. So this is the simple problem, but in the morning time, I tried it with a DP, right? So how much I test cases I able to pass? Let's see. My internet is bit slow. My internet is bit slow. Sorry. Oh, I able to pass out two 9 12 test case using the DP. So basically, it's not a DP problem. It's the graphical approach. I tried graphical approach. It's a bit complicated, but it's the easy question. Now let's see the question number DP to the DP. It's the most famous DP question. It is distance. You have to given to a string word one and words two. You have to return the minimum number of operation required to convert one word to second. So you have to permit it to allow three operation: insert a character, delete a character, replace a character. Okay. So in this approach, it's a simple. If we match the from the word one and word two at a particular index, we have to just leave from the both. That means I minus one and j minus one. Otherwise, we have three options. Like we can insert the element, we can delete the element, or we can replace the element. So now let's check the for this. Like what I am trying to solve, say that like int and what dot size m is equal to what 2 dot size. Then we have to return. Let's let's use the dp, right? Dp minus 1 and size of dp, right? And we have to return helper. What might be helper content? Word 1, word 2, and index 1 and index m. Now let's build first dp. Dp might be size. What is the size of dp? So it's a 500. Then we use 501, and second one we use 501. Now let's understand helper function, how to write helper function. So this s1 string, s2 int I int j, right? Now let's first take s1 I minus 1 is equal to s2 j minus 1. Then we have to take like what, just not a take take 0 plus helper s1 s2 I minus 1 j minus 1, right? So here in 1 take 1 e9 and the delete 1e9 minimum element, right? Insert, insert, insert 1e9, delete, insert, and what is the next? Replace. Replace is equal to 1e9. Now let's understand the situation here. What might be? Let's delete. So 1 plus helper, helper. Let's suppose we delete element from the word. Let's suppose we delete the element from 1. So what might be the case? 1 s2. If we delete the element I minus 1 and we have to j, right? Let's insert the element. Let's then 1 plus helper s1 s2. If we insert the element, so we match both sides. So if we insert, then I same to condition and j. If we replace element, so we can replace like 1 plus helper s1 s2 I minus 1 and j minus 1, just as replace. And here we have to return like return minimum of all, right? Take, delete, insert, replace. Now let's see the base condition. So this is the base condition. What might be the base condition? So one is like if we return 0, one might be the base condition like if we return the 0, if we return the 0, if we j like I delete करना होगा. If j equal to I, then we have to return like return j I. If j is currently on the j, so we have to return I. I को return करना होगा. And if 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 j 0 हो जाएगा and I भी 0 हो जाएगा and I 0 हो जाएगा, then we have to return 0, right? Now if I becomes the 0, I becomes the 0 and j is not, then we have to return like 1e9. Let's see this is pass the test cases or a wrong answer or a TLE or like something else. What this give? Let's check what is the might be the problem with my net. Let me see first. Okay, Mike, it's this gives the TLE. Why? Yeah, this gives the TLE. Why? Because we use the DP and initialize it, but never use this DP. That's why DP I J not equal to minus 1. Then we have to return like DPI J, right? That's why this is not turning like a GP. So now the question arises from the memo. Oh, I think this passed the test cases. Now let's submit. Let's try to submit it. Now the question arises with the what? Oh, sorry. Preparing for the runtime environment. Should pass the all test cases. Yes, this is correct. Now let's tabulate it. So we have to tabulate it. Sorry, let's tabulate it. 0 and plus plus. So dpi 0 is equal to I and for loop dp0 dp zm z plus plus dp0 and j is equal to j. Right, now let's see the critical condition. Oh, I think मेरा दिमाग काम करने बंद कर दे रहा है क्योंकि मैं मेरा माथा घूमने लगा है। ओ सॉरी, मेरा सिर पंखा खराब इसलिए क्या क्या। अब हम लोग चेक करते हैं कि अगर वर्ड का जो कैरेक्टर है जो i-1 इसका टू वर्ड जो कैरेक्टर 2 है j-1 अगर इक्वल होता है देन वी हैव टू प्रोसीड लाइक आई जे इक्वल टू मिनिमम ऑफ आई एंड जे एंड j, right? This now else condition like first delete option, second insert option, replace option. So all dp i-1 j-1 replace and 1 dp i-1 j j and 1 plus dp I j-1. Now dp I j is equal to minimum of dp I and j and the delete option, insert option and the replace option, right? So now let's return the dp of n and m m. So we have to put here 0. Now let's see this test case passes the test cases or the might be wrong answer. Let's check. Oh, this is the, did you call them in? Okay, sorry. Control replica use this. Is it pass the test cases or the fail? Fail. It's the fail. Why? Okay, okay, sorry. 29. Now I understand why. Again fail? Why? I don't understand this. It's some kind of a joke, some kind of joke like that. Again fail? Why? Let's see the evaluation test of mindset. Why? This one right? This two right? Minimum right? Delete. I think this will be right, right? I think this is right. Why are this the test is failing? Why the test cases are failed? Let's use here this line. Why? I think the DP is conflicting here, not the. Let's use this. Okay. I think the DP we are using is not just adjusting, right? That's what this was. The code is correct, but the main problem with the DP, it is submitted or not, I don't know. Let's submit again. Check if this submitted. Yeah, this judging pending. Yeah, this submitted.